Hello, welcome back to my channel. Today I'm going to present you the internship which I was done on embedded systems and I have done with emertex which is an future ready IT institute. Now today I'm going to say you about the what is meant by embedded system. Okay, now let us go. Now let us see about the goals of internship. Introduction, overview of embedded system, microprocessor versus microcontrollers, microwave oven as embedded system, development process and tools that are used, architecture of PICs in lab, project demo, and the final conclusion. Okay, now let us go to what is NPT system? Wow, now we are going into the amazing topic, mind blowing topic, which we are too excited. Are you all are also excited? Okay, now let us learn what is mean by embedded system. The embedded system, which is both hardware and software, which works through its functionality, and it is known as embedded system. We are all wondering what is embedded system. It is it's it is much simple as this, as I told. So it is nothing but a hardware and software. It works by its functionalities, where it is produced by hardware and software. Yeah, now it performs a predefined task, usually uses a very specific requirements. Mobile phones, MP3 players, digital cameras are very common in embedded systems in our lives. Okay, now let us go to the characteristics of embedded system. Reactive and real time, operates even in the harsh environment. Distributed, it has a small size and weight, and power concerns application and domain specific. These are the characteristics of embedded system. Now let us go to the examples of embedded system. These are some examples: wireless sensor networks, automotive applications, RFID, motor control, USB controller, remote access controller. As I said, the embedded systems contains both the software and hardware. It has their functionalities. It performs by its functionalities. So let us see what software functionalities and hardware functionalities. Both together can perform the embedded architecture. So, software consists of introduction to embedded systems, software development, hardware and software interface, programming paradigms, embedded operating systems, real-time scheduling, shared resources, and hardware produces of hardware components, power and energy architecture senses. These both hardware and software both together form, as I said, it is an embedded architecture. Now let us see the embedded systems overview. You can see computers are here, micro ovens are here, and even washing machines are here. Lot of these, they cost a lot, but by using embedded systems, we can reduce their cost and we can use it for household purposes. And you can read, as I said, you can read this slide. Yeah, now let us see about differences between microprocessor versus microcontroller. Now let us see the differences of microprocessor. The applications are used in the microprocessor are advanced data processing, video computer vision, personal computers, fast communications, multi-core computations. The processing power of microprocessor is higher, the memory is external and it is flexible, the power consumption is higher, the size is larger, and the price is very expensive. We need external peripherals with input-output pins. Now let us see the differences between microcontroller. The applications are embedded devices, control systems, smartphones, consumer electronics. The processing power is lower, the memory is internal and it is for only limited size. The power consumption is lower, the size is smaller, the price is cheaper. The input output is we use programmable digital and analog input output pins. Yeah, we have seen about microprocessor versus microcontroller. Now let us see about embedded system, which we can use it as microwave oven. I know it was an interesting topic. You will like it and you will love it. This, yeah, you can see an embedded system is a microprocessor or microcontroller based on computer hardware system with software that is designed to perform dedicated function. As we can say they have given examples like mobile phone, microwave oven, and GPS system. Okay, now let us see about mobile phone first. Actually, we have to explain about microwave oven. For you, as our real-time applications, we use most of members. Without mobile phone, there is no real-life application. So, for understanding more better, we take an example of mobile phone, and I will explain a remaining two also. No worry in it. And first, let us talk about mobile phone. The mobile phone, the parts which are inside that are made, it is um, developed by hardware, and the software where our we use apps like WhatsApp, Instagram, uh, Twitter, Facebook. These are all apps and which are used by the software. These are software and the parts which are used inside was hardware. By using hardware and software, we are using some we are performing some functions on it. When you open WhatsApp and when you chat with some member, it is dedicating a function that you are chatting with my one member. It is a function that you are doing. So in this way, the mobile phone was used, and microwave oven. As we know, inside the system, internal system was which was made by hardware, and the software, which means we make an temperature to heat the food, and we set time. By this time, we want the food. In this way, the application runs, and the tasty, and very the cold food becomes into hot food, and it gets heated. In this way, microwave oven was used, and GPS system. As you know, where we set one location, um, and our vehicle, as it says, a sound which comes outside was software. The points which are developed inside was hardware. It is done by hardware. Internal part which is done by hardware. The external sound applications which is coming out was done by software. Yeah, in this way, GPS system is used. Next, let us see about the development tools for embedded system. It is assembler, operating system, debugger, compiler, simulator, emulator. These are the tools. Yeah, now let us see about the tools used for project. MP Lab IDE, XCB compiler, Pixim Lab simulator, Peak 6F8 7778 microcontroller. In that we use for 16 to 4 CLCD tactile switch matrix keypad timers. CLCD, sorry, CLCD. Pix 16 F8778 mini development board with an LCD module 2 into 16 operating at 5 voltage. The control lines are connected to port pins. that is RC0, RC1 and data lines D0 to D7. Two port pins RD0 and RD7, whereas it is directly grounded. For real reliable performance, LCD has to be initialized with certain commands. We have to use certain commands so that we can use the LCD to display. For those operations, we need to write a code. Of This is MC Lab overview, and these will be active components, available components, project graph, MHC plugins, console, configuration options. And in this way, we can make the MP lab overview. By this MP lab only, we can load the hexa code, and we can display the timer box by some operations. Yeah, you can see this is a Pixim lab, which we use the Pixim lab. In Pixim lab, we use a PicGenius. PicGenius. In this, we load the hexa code and from the MP lab, and we will execute. See, as you can see, this green box where the display content is displayed in it. Yeah, thank you. Now let me show you about. Wait, just a minute. Yeah, hello. You can see the document where we have to show. Wait, give me a second. As I said, microwave oven project where we have to collect these. We have to create these build dictionary and NB project, CLCD main and matrix keypad and timers. These all we need to create, and these all to be uploaded in MP lab. We have to create a project, and we have to add in it. Um, Now let me show about Pixim Lab. Already I have created those files, and I have uploaded in the project extensions one by one. Uh, where in the configuration box it will be shown, and it is marked as the project, and that is my project. We have to create the matrices, trimers, CCLD, main H, CCLD, small h. So we have to create all these files. We have to write code for it. Now we will come to Pixim Lab. In Pixim Lab, in the microcontroller, we use PIC 16F8778, as I said before, and the board we use was a PIC Genius. Yeah, and now um, we have to use file, load hex, and this oven project and open. See, as you can see, this green box is powering on the microwave oven, and it is displaying for micro grill convention and start. Yeah, now you have to do. Yeah, now you have to set time. As it is, I am setting 5 seconds of time. Now you have to press a hash. Yeah, you can see the cooler and heater. It is turning. Yeah, it is. The time is up. Now the cooler heater will stop. Yes, as I said, in the micro oven, when the here when we keep our food to the certain time and to the certain temperature, it will be heated, and up to then it will be heated, and when we stop it, it will be stopped, and the food will be taken out. Yeah, you can see we can set even the temperature. Yeah, You have to wait a second. See, you can see the cooler and heater, which is turning on. Yeah, it is rotating. Till the time is there, it will be rotated. When the time is up, it will be stopped. Yes. Oh, yeah. Yeah, the time is up. See, three, two, we have taken three, and when we clear hash, see, the cooler is on to the temperature and the time is up. Yes. Yeah, let me show. Yes, the cooler and heater debug. See, power is on and it is displaying micro grill and open. Yeah, see, when we press 3, it is asking temperature. I'm doing temperature as a 45 and I press a hash. It is a preheating. See, you can see it is preheating. 15, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Yeah, set the time. We have to set the time now. I am setting only 2 seconds. Yeah, and now we have to enter. Yes, time is up. Yeah, our food is ready with delicious, and you can eat the hot food by programming. Yeah, in this way, our program is done. Yeah, thank you.